weather. People of all ages love to talk about it, and a lot of people like to complain about it when they think the weather forecast wasn't right. How do I know this? I'm a recovering TV meteorologist. Full disclosure, I'm currently not on air as a meteorologist or reporter, but I was on air at three TV stations in the Midwest. Then I moved on to doing science communication at science museums as well as in university outreach centers. Let's talk weather. Where do you get your forecast? Are you someone who likes the TV meteorologist, or perhaps you're someone who likes to have an app that you can check? The US Department of Commerce found that the majority of Americans check the weather forecast 3.8 times per day. So we know that this is a topic that the public is interested in and has a fair amount of familiarity with. So we're going to talk now about how the public's engagement with TV meteorologists and their communication of uncertainty, how that comes about. What strategies do they use to discuss weather, which is an uncertain thing? There's a lot of areas within weather that have uncertainty built into them. Probability. For example, if I said this afternoon's weather forecast says 20% chance of rain, you might ask yourself, well, what does that mean? Feel free to pause the video right now if you want to think about it. There's a lot of different answers that you might have for what that means. I've listed a number of them here. C is actually the answer that is the definition from the National Weather Service of the probability of precipitation. It looks at what happened in the past. But E is actually a more accurate answer. The phrase means different things depending on who the message is coming from. That's because the National Weather Service may provide a numerical forecast, they may have computer models, but as a TV meteorologist or just a meteorologist in general, you don't have to go with what the National Weather Service is forecasting for their high or their chance of rain. If you feel like another model is more accurate, you can give that information, or maybe you have a gut feeling about what is going to happen. What matters for a TV meteorologist is that they're giving their viewers tangible information that they can act on. Do I wear a jacket? Do I need an umbrella? Do I have to cancel this afternoon's birthday party? Another area of uncertainty in weather is the term normal, and that's something that actually changes. It's recalculated every decade and represents a 30-year average. Localized events versus broader events are another area of uncertainty in weather. One of my favorite weather phenomenon is thunder snow. Thunder snow is something that happens when you have a thunderstorm in cold conditions and everything that comes down is snow. Rates of snowfall are 2 to 4 inches per hour. So where in that localized location the thunder snow is occurring, those people can get blasted with just a ton of snow, and a few miles away, they might not have much at all. Time. That is the number one challenge for someone who is doing a TV weather forecast. This map here shows the designated market areas from 2013. Each color and each kind of polygon shape represents the viewing area that TV stations within that color are covering generally. If you look to New Mexico, you can see that the state is almost entirely dark blue. Those TV stations are expected to provide a weather forecast for almost the entire state. And New Mexico has valleys, deserts, mountains, huge geographic area, and a huge variety of different things happening within that area in terms of weather. Please note that these challenges, they are specific to the TV weather forecast. I am not diving into the new since I was on TV, the fact that many of the TV stations have their own cable channels with 24-hour weather, so they can spend more time on it, or social media where they can be on Twitter and they can engage with their viewers. That's something separate. I'm specifically talking about the challenges of the TV weather forecast itself. Another area that's a challenge is a mandate from management, news directors, and they think that this is how the public is. Real sometimes perceived. Steve Decker, the director of meteorology and undergraduate programs at Rutgers University, noted that they oftentimes think that the viewers want it cut and dry, that they want yes and no type answers. They want very clear cut answers to something like weather, which has a lot of uncertainty built into it. The most valuable publication that I found while doing research for this talk is called Communicating Uncertainty in Weather Forecasts, a survey of the US public by Morse et al., and comes from 2008. Morse et al. Argue that actually the viewing public is a little bit more adept at dealing with uncertainty than maybe those TV news directors think. 95% of people surveyed, when given a single value forecast, for example, that high on Sunday, they actually inferred a range of possible values. They kind of had this innate understanding that there is some uncertainty in it. 90% also had decreasing confidence in later forecast times. They trusted tomorrow's forecast more than the 7-day forecast. That also aligns with what we know in terms of the ability of our computer models to make those forecasts. Third, the highest confidence was in temperatures, less so in precipitation chances, and least in precipitation amounts. Once again, people just inherently seem to know which types of things meteorologists are more able to accurately predict and what variables have more uncertainty to them. When we're talking about uncertainty and something is happening that is out of the normal. So, weather's not following the normal trend of climbing temperatures all the way into the mid afternoon or early evening and then dropping down. An example of that might be a cold front that's arriving sometime in the midday and causing a significant change. So, if it arrived earlier in the day, the forecasted high might be at 1 o'clock, and all of a sudden temps really drop off for the evening versus happening much later in the day. The authors note people may like receiving an explanation of the weather situation as part of these uncertainty explicit weather forecasts. This interest in explanations is corroborated by the popularity of television weather forecasts. So the viewing public chooses to get their weather forecasts from TV because they're actively searching out that story, that explanation of uncertainty. They're not scared off by it, as some maybe news directors think. They actually want somebody to walk them through, tell them the story, let them know what's going on. So, what can TV meteorologists do? Well, a few strategies are employed. First, they build uncertainty information into graphics. So you're looking at a 7-day forecast from WRAL, and you can see at the bottom it says precipitation, and then there's percentages going from 90, 80, 50, 30, 30 as they go Sunday through Tuesday, and a green line representing decreasing chances of precipitation. Another strategy is employed by the National Hurricane Center. It's called the National Hurricane Center Track Forecast Cone, but most people know of it as the Cone of Uncertainty. This is a product that is put out by the National Weather Service. It is too complex and overwhelming, though, for the TV audience because it has so much information. However, in the publication, Achieving Accuracy Through Ambiguity, the interactivity of risk communication in severe weather events by Baika et al., they note that TV meteorologists are able to take this type of information and translate it. So this is an example at Local 10 where they are showing maybe not all of the information. They've got the cone, they've got a yellow line representing the center, the eye of the storm where it's expected to go. But in that research, it was found that this cone of uncertainty leads to uncertainty. So, for example, a person in the Bahamas may be located right underneath the letter M in Bahamas, and because they're not within that grade cone, they might think, hey, there's no chance of this storm actually impacting me. Whereas the cone actually represents where the eye of the storm is potentially going to go. So, cone of uncertainty leads to uncertainty. Opportunities to fix this have been employed. So one is the use of TV graphics spaghetti plots. So this is a graphic that was shared by Fox 35, and it was shared on Twitter, but used on air as well. And it's showing different weather forecast models and what they're all showing as to where the storm might go. Again, though, uncertainty is involved. TV weather forecasts are not two-way communication. So people who looked at this might have thought, what does this color coding mean? Are the things that are listed on the left more accurate and on the right less, or maybe red is the most accurate? So again, confusion going on. This is an example of someone from John Morales from NBC6 who actually tried to combine the two different techniques. So there's the spaghetti plot plus the NHC predicted center of a tropical cyclone, so that line in the center of the cone. And so what he is showing in this particular image is that the National Hurricane Center is expecting that the storm is going to go a little bit further south than what most of the computer models are showing, indicating that they think that a different computer model has a better handle on the storm and is doing a better job of accurately sharing it. When John Morales shared this through Twitter, he was actually able to have a back and forth conversation with viewers who were a little bit confused as to what it was showing. Again, if you don't have that back and forth in TV, though, there is a challenge. Another strategy used in TV weather is to translate numerical ideas to common words. So rather than 10 to 30% chance of impactful rain or snow, call it a slight risk. You can also use other qualifiers like scattered, isolated, or widespread. Dan Breeden from WXOW in La Crosse says he tries to use these in whatever combination best fits what he thinks is going to happen. So he might say there's a slight risk for scattered showers, and that's going to give the general public, his viewers, a better idea of what is to come. Another strategy used is take those graphics and combine that verbal explanation to create and narrate a story. So you've got your green line representing the chance of precipitation, but the meteorologist is standing in front of it and telling the story of why that is expected to happen or not to happen. And finally, in TV, we acknowledge that we don't always get it right. We can acknowledge and explain what in the biz we call a bust, when you get it wrong. And oh man, the viewers let you know when you get it wrong. So this is a graphic explaining why the forecast fizzled and is actually talking about how the 7-day forecast is accurate about 80% of the time. Most likely she might have been talking a little about the psychology of us remembering when things are inaccurate. TV meteorology has a lot to teach us about communicating uncertainty, but how does this translate to other fields? Join us for part 2 on this topic for tips on what you can do in your work outside the field of TV meteorology. I'd like to offer a special thanks to the Alan Alda Center for Communicating Science and the Kavli Foundation for their support in connecting science communication research with practice.